the world. It gives me a great to you all a very warm welcome. Ladies and gentlemen, I, on behalf of Director SAARC Energy Centre, thankful to all of you for joining us in this webinar on Urbanization-Energy Demand Nexus, the challenges and mitigations. My name is Ehsanullah Marwat. I'm working as Research Fellow Energy Efficiency at SAARC Energy Centre, Islamabad. I shall be moderating today's session. Dear participants, as cities in South Asia and across the world continue to expand rapidly, the relationship between urbanization and energy demand becomes increasingly complex. This urbanization energy nexus presents significant challenges, particularly in ensuring sustainable energy access with simultaneously addressing the environmental impacts of urban growth, such as rising emission and strained infrastructure. Urban areas with their higher population densities and concentrated economic activities are already responsible for a large portion of global energy consumption. And as urbanization accelerates, this demand is only expected to grow. In South Asia, where urbanization is occurring at an unprecedented rate, the future EC and currently, per capita energy consumption in urban areas is almost double that of rural population, emphasizing the unique demands that cities place on energy systems. Without effective planning, this surge in energy demand could hinder not only the sustainable development goals of the region, but also the global efforts to reduce carbon emissions and mitigate climate change. Therefore, the need for comprehensive policies and smart urban planning is critical. Cities must focus on energy efficient technologies, renewable energy and sustainable urban development strategies that can accommodate the growth of urban populations with ensuring energy security and fostering economic growth. Today's discussion will explore these challenges and potential mitigation strategies, as well as opportunities for innovation that can help cities thrive in an energy-constrained future. Dear participants, I'm delighted to announce that we are honored to have Dr. Nawaz Ahmed, Director of SAARC Energy Centre, with us in today's webinar. He is the driving force behind this initiative. Thank you, sir, for joining us, Dr. Nawaz Ahmed. Sir, may I request you for opening remarks? Over to you, sir.
Thank you very much, Mr. Ehsan, for arranging this webinar. Dear participants and presenters of the webinar, good morning, everyone. I am Dr. Nawaz Ahmed, Director, SAARC Energy Centre. I welcome you all to this webinar on Urbanization Energy Demand Nexus, Challenges and Mitigations. As we all know, urbanization is rapidly transforming the landscape of the cities, bringing with it both opportunities and challenges, particularly in the area of increasing energy demand. The increase in energy demand is mainly due to energy-intensive buildings and transportation, industrialization, and urban heat island effect. If we look at the global energy consumption, cities account for nearly 2/3 of global energy consumption and contribute to around 3/4 of global carbon emissions. Not an exception, urban planning and population in South Asia has been significantly increasing, so has been the energy demand. This rapid increase in energy demand, coupled with the region's dependence on fossil fuels, poses significant challenges for energy security, sustainability, and environmental safeguards. Nonetheless, there are substantial opportunities to deal with these challenges, driven by innovations in energy efficiency, effective urban planning, and a strong commitment to integrating renewable energy solutions. Dear participants, this webinar is aimed to explore how South Asian cities can address the energy challenges posed by urbanization while transitioning towards cleaner and sustainable solutions. In this event, we have invited experts from Sri Lanka and Australia. They will share their knowledge and experience with the participants and respond to their questions. I am delighted to acknowledge the great cooperation and support extended by them. In the end, I thank you all for joining this webinar. I expect this webinar to be an interactive session, so please feel free to join the discussions and express your valuable opinions. With these words, I declare the session open and wish you all a very comfortable learning and knowledge sharing experience. Now I request Mr. Ihsanullah, Research Fellow at SAARC Energy Centre, to take us through the agenda. Over to Mr. Ihsan, and thank you all again for joining us today.
Thank you so very much, Director SAARC Energy Centre, for your visionary thought. Dear participants, before proceeding with the agenda, I would like to draw your attention towards some important points related to today's session. Please note that the agenda of this webinar is already available on SEC website. All presentations and its recording will also be uploaded on SEC website. There will be a brief question and answer session after the presentations. You will have the opportunity to ask questions to our presenters by typing your question under the question tab or chat tab of the Microsoft Teams panel on your screens. Please also mention the name of the presenter to whom you would like to address your question. You may send in your questions at any time during the presentations. We shall be asking questions on your behalf. Ladies and gentlemen, I am extremely grateful to our elite panel of speakers, including Mr. Gunateleke, former Additional Secretary, Ministry of Power and Energy, Government of Sri Lanka, and Dr. Abbas Ehsan, who is Applications Engineering Lead at Energy Australia for this session. I shall be introducing them in detail before start of their sessions. I would also like to inform you that our third speaker, Mr. Rahul Agnihotri from UNEP India, will unfortunately not be able to join us today, as he is currently in Odisha, where Cyclone Dana has severely impacted the coastal region, leaving him without internet and electricity. So let's start with the presentation from our experts. Our first presenter is Dr. Abbas Ehsan. Dr. Abbas Ehsan is an experienced energy professional currently working as Applications Engineer Lead at Energy Australia, where he leads technical, economic, and commercial evaluations of innovative projects in the energy sector, with a focus on urban electrification and emerging technologies like behavioral demand response, virtual power plants, community battery, and electric vehicles. With over 15 years of expertise in renewable energy, integrated energy modeling, and financial and commercial analysis, Abbas has successfully driven strategy and innovations in energy portfolio. He holds a PhD degree in energy systems specialized in techno-economic optimization of hybrid renewable energy systems and carbon abatement solutions. So I would like to request Dr. Abbas Ehsan to proceed with his talk on smart urbanization, managing energy demand with efficiency, mitigation, and future trends. Over to you, sir.
Thank you so much, Mr. Ehsan and the SAARC team for having me today.
Abbas, you
First,
are not
can I
audible.
confirm? Cannot hear me?
You check if you are unmute.
Yes, I am unmute.
There is some issue with your mic, or if you
Can you hear
haven't
me now?
unmute.
Can you hear me now? It's weird.
We are unable to.
Can you hear me now?
No.
No. I think I need to rejoin. Hello. Can you hear me now? Can you hear me now? Oh, wow. I'm unmute, but
Mr. Abbas, you are, I believe, audible to the audience.
okay. Can anybody confirm that, please? I think yes. Okay. So Sampath has confirmed that they can hear me.
Abbas, you continue.
Okay, I can start. Thank you, Meryl, sir. I'll start sharing my screen.
Audible. You are audible.
Yeah.
Yes, please
Yeah.
go ahead.
Okay. I'm not sure if this was an issue in the first place,
Yes,
but
sir.
apologies everyone for this. Technology things happen, and we can't have much control on this. Thank you, Mr. Ehsan and the SAARC team for having me on for this amazing opportunity. I really look forward to contribute my knowledge in this webinar, and let's keep it as an interactive session. As the host mentioned, that you can post your questions, and I'm more than happy to answer any questions related to the talk or any general questions on related to the energy uptake, either globally or South Asia. I'll share my presentation now.
Yes, it's visible.
Perfect. So the topic for today to discuss for me is on smart urbanization. I'm going to speak about managing energy demand with energy efficiency in the first place, meaning some energy upgrades that we can do either at residential or commercial scales, some of the mitigation strategies that we can adopt to help meet this increased urbanization trends, and then some of the future trends in order to tackle this problem. I'll start with the contents of my presentation will be introduction to this problem, The problem statement has already been shared in the webinar concept paper, but I will briefly highlight that problem. Some of the energy management challenges that are across this urbanization nexus that we are having across the South Asian countries in particular and globally in general. So just to be sort of clear that this problem is appearing around the world, even like in developed countries like in the Europe, Australia, and even in the US. uh, these management issues are like quite up to date, and people are like working on smart energy solutions. So it's not a unique problem, but in order to discuss it, we need to look around and learn the sort of the methods, the techniques that have been adopted around the world in order to tackle these challenges. I'll talk about some of the load segmentation in the urban settings. Then what smart energy solutions can be sort of applied in order to reduce this increasing load for urbanization, and some of the mitigation strategies to reduce urban energy demand, followed by the future trends and some of the final thoughts and next steps. Now, with increased urbanization and of course, with rapid population, which is the major cause of any sort of the context and the energy requirement in particular, we have a limited infrastructure installed in a particular energy in a country setting. We have we design that for some expected based upon the planning cycle that we look into. We develop that infrastructure for that. But as we know, the population growth is the key factor contributing not only to the basic economic factors of any country, but also depending upon what energy needs for that particular populations can be devised, and what planning strategies can be implemented in order to conquer that problem. So this is rapidly happening in across globally, but particularly in SAARC based nations, India, Pakistan, Bangladesh, Nepal, and other participating countries. And studies has shown that the demand projected with this urbanization, that people either moving towards cities based environments, or the existing setups that we have are being developed in terms of the city style livings and city style lifestyles. So that demand is projected to increase significantly over the coming years, 2030, 2040. And that's why we are trying to tackle that problem now, and that's why that's a very relevant topic to discuss. The main impact from urbanization, in addition to like what's been already discussed in the concept paper by the SEC, are the increasing demand on electricity, which is the main commodity for any community, any society. Because when population goes in, the electricity needs will come in, the demand grows. Similarly, another commodity is gas, which is quite, I would say, quite a challenging one in these days, because gas is limited in its from its primary resource, while also its carbon intensity is pretty high as well. And studies have shown that from the generation side, it may be very feasible, but in a primary use setting, it can pose challenges. That's why not only from the energy efficiency space, but from the costing space as well, gas can be pretty challenging. And of course, followed by the transportation demand that any urban society would increase. Your transportation load increases, which is subject to lots of burning of fossil fuels. This also poses challenges because particularly in the context of South Asia, infrastructure strains and inefficiencies in energy supply. We all are well aware that our transmission distribution networks are not that efficient, let alone the development of new ones. The old ones are really deteriorating, and the losses are pretty significant. So that poses a further challenges to this urbanization. All this combined requires a need for innovative solutions, as mentioned by the chair of the webinar and the host of the webinar, that innovative solutions are required to balance this urbanization and meet the energy demand. Now, I would like to switch to some of the current energy management challenges in urban areas, which is another, sort of that step deep dive to the current problem that we are trying to solve. The key challenges is, of course, we are burning lots of fossil fuels. As we all know, like from the generation side to the supply side, there are lots of, we are burning fossil fuels, and the reliance on that is pretty dominant, especially coal and oil for power generation. As we mentioned previously, our infrastructure, the transmission and distribution networks are outdated. So the transmission losses are pretty significant. So imagine if 1 unit of electricity is produced, when it reaches to our homes, we hardly get it like in its proper form. There are so many losses in between and so many mismanagement in between that its use, or then we ending up paying overpricing, is quite significant. So it is one of the key challenges to this problem as well. While the inefficient appliances that we are using, for example, our gas heating systems, our electric cooling systems, our water heating within our buildings, our homes, our commercial settings, apartment based settings, it's pretty inefficient in the current shape and form. So we need to address this very clearly in a precise way, in a proper process, so that we can overcome the urbanization challenges. The gaps that we can mention here are the unplanned urban migration. So in the long term, plans for cities, countries, we do give a forecast, or we do give a prospect of how can the urban development of different small cities to a big economies or big cities can be planned. But the non-effective sort of investments towards development of those areas is quite a challenge at the moment. So that leads towards gaps in between, given the population growth, as we mentioned previously, and the development of the infrastructure to meet that population growth. There is always unfortunately a misbalance in that. So given that our resources are limited, we struggle in meeting the energy demand of the normal public. Now, the lack of energy efficient building codes and weak enforcement is rapidly in rapidly urbanization areas is leading towards the same problem. In my next slide, I wanted a deep dive towards the urban load segmentation. Now, this is by no means a strict segmentation. It's just my view regarding what sort of loads are important to address in order to come up with more energy efficient appliances, and in order to develop mitigation strategies, so that we can control, or we can have a better view or a better process towards addressing this urbanization problem. Now, most of us would already know that the key loads that in any urban setting or in any livable societal settings, the main ones that we have as a loads are space cooling. Space cooling is done currently through air cons or some other traditional cooling systems. They are mostly electric, but we would appreciate that most of them in the current form and shape are not that efficient. Because even if I pick a typical refrigeration cycle, a refrigeration system that's installed in a commercial complex or in a house setting, they are using the pretty inefficient heat exchangers and pretty inefficient refrigerants in them that requires more electricity for them to be powered. For example, I can quote that in the latest developments in the space cooling and heating applications, some of the working fluids of the refrigerants, for example, propane and carbon dioxide, are being used to have more efficient, and they are 2 to 3 times more efficient than the current space cooling and heating systems that we can use in order to get more efficiency out of our electricity and meet our energy demand in our urban settings. The next one is space heating. As we all know, space heating is very crucial for any commercial or residential settings. Mostly the primary source of heating is either electricity through heating elements or electric duct heating, or mostly the most common ones that in the South Asian settings that we use is gas. Gas is actively used for heating via the portable gas heaters or the gas ducted systems or commercial grade gas heaters that are being used. But as I mentioned previously, gas poses its own challenges, and the primary consumption of gas can be challenging due to its limited resource availability, which is currently posing a significant cost, and it's challenging economics around its pricing on the affordability for a normal consumer. It's getting really hard. And this phenomena is not only happening, in South Asia, but it's happening globally as well. For example, in Australia, I can say that the gas, if we use it for gas heating, it's really expensive. It's like 3 to 4 times more expensive than electricity. Although its heating value is higher, or in terms of its usability, it's very low, but it's the infrastructure required, and then particularly in the Australian setting, the infrastructure required to bring gas from from all the way from the Pilbara region, which is quite far away from where I sit today, to my home is really expensive. So these two, space cooling and space heating in the urban settings, are two very important loads that we need to address in order to tackle and go towards more energy efficient solutions. The other one is water heating. Water heating is the second most important load for any household, and traditionally electric hot water heating or gas, and in the South Asian setting in particular, again, is being actively used, followed by gas cooking. We know that cooking is mostly through the natural gas, and the other category includes lighting, washing, and drying, which is sort of that third tier or the fourth tier of the typical household demand. Another tier which is sort of separate but in the same setting involves is the transportation, which is quite significant, and mostly actively fossil fuels like petrol and diesel and the compressed natural gas or liquefied natural gas are used to meet these transportation needs. I'm now going to switch to some of the solutions in order to tackle these challenges for challenging, for the urbanization in the energy efficiency space. How can we and what technologies can we use in order to meet our energy demands most energy efficiently? Because reducing reducing the energy needs, the energy consumption while still meeting our needs is what the efficiency would speak about. And for that, as I mentioned some of these points previously, in order to tackle the space cooling and heating, and this is actually the learning from European countries, some of the US and Australia as well, where in the urban settings in particular, influx of these basic appliances like reverse cycle heating and cooling is effectively adapted in order to particularly in the new buildings and new constructions, in order to have more energy efficient and energy star rating based housing or community buildings or commercial complexes. So in order to, as I said previously, the modern reverse cycle heating and cooling systems, be it the split style systems or be it an all-in-one sort of ducted style reverse cycle heating and cooling systems, it is far better than the traditional heating and cooling because firstly, the technologies have been, the heat exchanger technology has developed quite a lot. While number two, the refrigerant that we use, which and to my knowledge, propane followed by carbon dioxide are very efficient, and they can reduce the primary energy consumption while still meeting the energy demands of a particular household by 3 times, because the COP, which is the coefficient of performance of these systems, is really high. Another one followed for hot water load, which is quite significant, technologies across the hot water heat pumps, which is essentially again the reverse the refrigeration cycle, is can be effectively used in order to tackle the water heating problem, which is currently primarily using gas, and gas is really inefficient and expensive as well. So in order to use a hot water heat pump, uh, it's very similar to any refrigeration cycle, but again with the technological developments, it's pretty efficient and cost effective as well. Now, I know the capital cost of these systems can be, a question mark here, because the more efficient we go through, the more sort of cost challenging, particularly from the capital expenditure cost, it can be significant. But there can be programs developed over the path when we start adapting these systems in order to tackle these problems and help consumers and help the overall urbanization problem to be solved more efficiently and cost effectively. This is followed by, now if anyone is interested, I can talk about hot water heat pumps more after ending my talk, but it's a very similar refrigeration cycle system. You have an evaporator, condenser, compressor, and a compression an expansion valve. uh, it comes in two sort of configuration. It can be a split configuration, very similar to a split heating or cooling system, but both of our both of our units of the split system are placed outside. There's a water tank in it in which water is stored at any particular temperature that we require, and it's operated against the delta T of the ambient temperature. So you would appreciate that in winter, when the temperature of the ambient goes like around let's say 2 or 3 degrees or even 0 degrees, or at places where it's negative at night times in particular, that's where the most efficient heat pump will kick in and give you hot water when it's mostly required. But in a normal setting, it's still very efficient on an average, particularly the temperatures across South Asian regions. Most of the heat pumps would work pretty efficiently across 2 to 3 times more as compared to what we are doing currently using gas or even the traditional electric element technology, which is like very inefficient, unfortunately, and costly as well. So you can see with these problems, we are not only addressing, energy efficiency, which is our primary problem, but we're also tackling some of the running costs. Of course, there is a capex sitting in front of them in order to make these technologies happen in a particular pathway, but it will be efficient in a long run, and for a longer planning period, it should solve the problem. Uh, Other than these two, we can also think about induction cooktops. So we discussed that the current cooking that's being implemented in most of our households, as we would know, is based on gas, natural gas, or LNGs, or any traditional, even the fossil fuels are used in order to for the cooking load. But in a most smart energy efficiency, in that context, we need to convert to induction cooktops. These are electric based cooktops, and they are pretty efficient. They still use the heating element, but their design and their the element technology or the material being used is much more efficient than of course any of the gas based appliances that we use. In addition to that, most of us would know insulation. For example, double glazed windows, and using insulation through our walls, and that all that sort of insulation based technology can also reduce or limit our need to utilize, for example, the heating and cooling loads in the first place, which can save significant amount of electricity. There's another one that's very active, is conversion of our current, the traditional lighting to LED lighting, which is also quite efficient. Now, this was from pure technology space for a typical household building. But if you talk about the next segment of this, which is from where the electricity comes, It is from the grids or from our distributors, which also requires, as we mentioned previously, a significant upgrade in order to make these things happen. So in the context, if I quickly mention that if my transmission losses are significant and I'm sort of paying a significant amount of the inefficiency on that, then if even if I install an efficient reverse cycle system, the misbalance will still be there. So in order to have an end-to-end efficient solution, the emphasis should be towards development of efficient distribution networks in which both from the generation assets and the supply assets can be balanced most efficiently. That can also lead towards, with the modern distribution networks and the modern technologies that are being implemented, we can develop demand response strategies, which is one of a very key element which I think would really help in context of not only generation management but supply management as well. But that would require active sort of involvement of the distributor, the network operator, and the consumer in order to make those kind of strategies happen. I'm going to talk about demand response in my next slide as well. So I'll quickly go through the rest of these parameters, which of number one is smart meters. As we all know, accuracy in the management and of electricity import and export is crucial. That's where smart meters are really important to be implemented. This can also lead toward smart home energy management systems, which is a really up to date topic in developed economies, in order to manage your strategies on when to consume, when to generate. If you are a generator, for example, having a solar PV on your rooftop, how can you help the grid, or how can you help the grid not only by, let's say, reducing your energy demand or shifting your energy demand, but also by exporting energy to the grid when it's most needed, in a virtual power plant network style thing, in which a few complexes, a few building complexes can come together and form a VPP, which I'm going to talk about in my future trends, but that can also, drastically solve the problem quite efficiently. I know this all comes with lots of challenges, and it's not in a click of a button, but it's worth pondering on them sooner rather than later. An example that I wanted to mention here is a case study from Victoria here in Melbourne, where it's been almost 3 to 5 years that a program by the Victorian government for introducing rooftop solar PV, battery, hot water heat pump systems, and reverse cycle air con systems have been implemented. And it's of course a subsidized programs, and I appreciate not every economy, not every country can afford that, or is not in a position to do that. But this can be one way of doing, or one way of starting with happening of these things. For example, they started back in the days like 5 years ago with rooftop solar PV, and there was a huge influx of solar PV systems, which not only reduced their carbon footprint from the primary generation side, but also increased, with the increased urbanization, it also, informed the consumer that they can be, they can be the controller of their, both the consumption and generation. So, for example, a feed-in tariff was introduced, which I'm sure most of us know, is when you have excess generation from solar PV, your distributor allows you to export electricity during middle of the day when you don't require it to use. Or if you have a battery storage installed, you can store your electricity during middle of the day and then use that surplus electricity from your battery later in the later part of the day. This not only results in significant electricity saving from the grid for the consumer, but also warrants more green generation and effectively significant reduction in the carbon emissions as well. Another one which we briefly discussed previously was the hot water heat pump system and the reverse cycle air con programs. These are currently being actively underway by Victoria and particularly in Melbourne and across other cities in Australia as well, in which the government is encouraging to install, instead of gas, they are encouraging to go all electric. And for all electric, they are taking steps to conversion of the water heating loads to get electric, and then the gas heating and the electric cooling, which is currently twofold, two different sort of things. They are combining it and towards using a reverse cycle air con programs in order to meet both electric and heating loads, cooling and heating loads of a household. Now, I'll now switch to mitigation strategies to reduce the urban energy demand. We talked about how can we, be more efficient in our current setting with the increased urbanization, but there are further strategies that can be implemented in order to reduce or mitigate our demand by shifting it to other times, or by doing other smart sort of applications in order to mitigate our our overall energy demand. Firstly, distribution energy generation, which I think most of the countries in South Asia are already across, with the huge influx of solar PV and battery storage systems and our commercial and residential buildings. This reduces the primary energy demand significantly. But as I said previously, the core part of it is infrastructure development, which unfortunately is lacking. And it is appreciated that that is quite capex intensive, and but over time that should be resolved in order to make the this distribution energy generation quite smooth and effective, which is basically a win-win situation both for the generators and the consumers. There's one challenge across with the huge influx of solar PV, particularly during middle of the day, where basically the net demand, and when I say net demand, it is the gross energy demand of any city or any state minus the subtracted from the renewable generation during middle of the day by rooftop solar PVs. So for example, if we have 100 homes in an apartment complex and they all have their own solar generation during middle of the day, it's a good sunny day. So there are events like examples from Australia that the middle of the day the net demand is basically none, or it's very minimal on the grid. So of course we have electric systems, it's run by electrons, and it's run through stability by having some prescribed frequency systems. So and given the sort of the challenges across renewables, which is number one is the fluctuation in its generation, it poses challenges. But nonetheless, it still is very efficient in terms of in the context of, I would say, South Asian economies, where you can primarily use all the energy in your household and store any surplus in the battery in order to limit your dependency on the grid. Given the the challenges on the grid are resolved, once that's resolved, we can have a better interface between the two and develop and go towards that smart solutions. The other one, which is the energy management, most of this we already discussed by uptake of energy efficient appliances that can it's not only becoming more efficient, but as I discussed on the demand response side, we can shift our demand from, for example, from the if I have a rooftop solar PV installed at my house, I can easily shift my washing load or my drying load or my other loads that I normally do at night time or early morning time. I can shift it to the middle of the day, which would automatically reduce my dependency on the grid or the distribution network. Now, the other pattern that is normally followed in deregulated markets is basically when the price of the electricity market is really high, and your distributor will charge you quite a lot of money when the load on the grid is very high, what normally the strategy would be to, as a mitigation strategy, we would shift our load to those low price periods where the grid really r- doesn't really matter, like what sort of consumption they do, because they are offering you a very low price. So we can shift to those periods in order to reduce our bills, and in order to mitigate and reduce the urban energy demand. So the benefits would include, energy reductions with these kind of strategies, less reliance on the grid, and cost savings for the consumers. Like for example, in Australia, the prices of the network can go negative at sometimes. So, and in those price periods, people are encouraged to, run their course during middle of the day or whenever the price is negative, charge their storage if required, and they basically earn money while doing that. Now, this is something which can be looked into, in a South Asian context after, as I said, the distribution networks are developed and this interface between the consumer side and the generator side are cleared, where this sort of interface and these sort of strategies can be looked into. Another one, very quickly, electrification of transportation. Um, the the transportation load, which is quite challenging due to the direct fossil fuel burning, the uptake of EVs is quite up to date in the market these days, and there are lots of companies, lots of Chinese companies coming into the market and pretty established planning and strategies in order to be part of the economies. So, and that can result in significant savings of the fossil fuels in the first place, while also strategies like integration with the grid can further reduce the demand. For example, if you have a EV which roughly comes with 50 or 60 kilowatt hours of a battery, at times if it's allowed with the network and you have the systems in place, for example, a two-way charger in place, you can actually use the electricity from your EV in a time period where the network is unable to provide you power, for example. Now, this is again something pretty advanced, but even conversion to EVs can significantly reduce the dependency on the fossil fuels, which can reduce the primary energy consumption in the first place. The other main one with this one, along with solar PV and demand response strategies, is that it contributes towards reduction in carbon emissions and going towards that green economy. Um, the another one, which is sort of a further step of all these previous steps, is development of a virtual power plant. As I briefly mentioned previously, when we combine all these together in a what I call a smart urban energy nexus, we can come up with a virtual power plant adoption where consumers can participate actively, both as consumers and generators. So for example, if there are 10 batteries installed in a 50 household setting, they can actively use their batteries to sell electricity to other households who don't have electricity, and they will mitigate the primary energy consumption in the first place, while also be more economically more efficient. This would require smart implementations and smart sort of applications, of course, through either machine learning or artificial intelligence and all those sort of modern facilities in order to make this happen. The last one that I want to mention in the mitigation part is, the global initiative towards reducing carbon emissions, which is of course not only through uptake of renewables, but also a smart usage of the electricity definitely contributes towards reduction in carbon emissions and reductions in cost savings in some context as well. I will now quickly switch towards future trends. I think I'm on time. Ehsan sir, please let me know if I'm not.
Yes.
Perfect.
You can
In
take
this
time.
slide, I would, wonderful. Another one that I wanted to talk here about, which is the future trends in urbanization and the energy demand. It's basically looking into, like, what steps or what sort of learnings can we take from the global markets or the global economies in order to tackle this urbanization and develop, like, both the energy efficiency sort of applications and also mitigation strategies. So firstly is renewable energy integration, which is basically scaling up our solar PV systems, wind, of course, from the grid side, in the urban grids, while taking advantage of local resources. Now we know that, like, most of the South Asian countries are pretty rich in its solar resource and wind resource and other resources like hydro, for example. So they can be actively used and needs to be scaled up in order to make sure that we have renewable energy and basically a replacement of what the fossil fuels are currently doing. It can be both at the generation side and the consumption side, which is basically at the distribution level. So this uptake would rapidly help uh, you know making it more efficient and save on the primary energy consumption of a consumer. Now, an example is I'm showing here is a record influx of rooftop solar PV in California in the CAISO market, which is the Californian Integrated Energy Systems, and the Texas ERCOT market. These are deregulated markets in which they basically, like, tackle how the solar rooftop solar PVs can contribute towards the primary energy generation towards their urban load requirements. Another one can be a hybrid distributed energy systems. So, and this can be in combination of different technologies. Now, hybrid is a relative terms in the context of particular distribution energy systems, where it's primarily dependent upon solar PV type of rooftop systems, but it can be actively combined with battery energy storage systems. Now, we didn't focus a lot on battery energy storage systems because of its significant, capex. But one thing that's worth to highlight here is that batteries are really helpful in sort of balancing out or in the stability of the grid when we have lots of uncertainties and lots of fluctuation from the renewable energy side. So the problem with solar PV and wind by its own is its active fluctuation, because the resource is not controllable. Wind we cannot control. Solar global horizontal irradiance we cannot control. So in order to balance out that and help the grid to maintain a particular frequency of the grid, battery energy storage systems have proven to be really helpful, both from the generation side and the consumption side. So a battery in a household setting can be really helpful as well, which basically means we can not only meet our energy needs when the primary energy consumption or the primary energy resource is not available, but that also means that we can help the grid basically with what we call the frequency ancillary services. We can participate in that and also, basically help the grid to be more stable. Now, I know these systems are not in place in most of the South Asian countries. But again, this is something that can be looked into. And in order to make it feasible, a particular technology, for example, battery energy storage system, which is again very capital intensive, we can make it more economically feasible if there are grounds for it to make economic benefits in the long run by doing different things and not only one thing. There can be a hybrid between the grid and the solar PV itself, where but the communication interface needs to be clear as well, which I know is a challenge at the moment. Oh, there we go. I mentioned the storage technologies here. I thought I didn't. So the role of battery storage in balancing intermittent renewable technologies is pretty crucial. particularly with uptake of renewables. So we mentioned this already. An example is the Tesla's power pack. I think most of us would know about that, in which Tesla have made a battery which is coupled with a rooftop solar PV, and it actively optimizes the use of the battery system when required in order to balance out the grid and also meet the energy needs of the consumers. This can be followed towards virtual power plants, again forming a smart energy nexus. uh, you know, Concepts like predictive load management through artificial intelligence and optimization in high density urban areas. It can be really crucial and really important when we form all this nexus together, like starting from the energy efficient appliances, mitigation strategies, including demand response, smart grids, and smart participation of these each assets. The virtual power plant in a setting with a load management strategies through artificial intelligence and machine learning can not only result in tackling the core problem, which is urbanization energy needs, but also address the economic problems and the carbon emission problems. Um, and using modern techniques like machine learning to anticipate and smooth out the energy demand fluctuations, which we briefly mentioned before, how the battery can play a role, for example. I think this is my last slide, which talks about the final thoughts and what are the possible next steps. I know there can be more to this, and so this is my view, and we can add more or subtract anything in the context of any particular settings that we are talking about. Now, smart urbanization is essential for balancing energy needs, as we understood, especially as South Asia countries continues to urbanize at a fast pace. Smart solutions like renewable energy integration, smart grids, and efficient building systems are essential to manage growing urbanization needs. Now, this includes integration of rooftop solar PV, which results in substantial energy savings and decreased reliance on the grid, which I mentioned that during middle of the day, we basically, your reliance on the grid can be really, minimal when we have our on house or on building rooftop solar PV, which is already in place in most of the South Asian countries. This can be followed by energy efficient appliances that we discussed, that includes reverse cycle air cons, hot water heat pumps, insulations, the other lighting, LED lighting based systems, which can result in 2 to 3 times reduction in energy consumption because they are more efficient as compared to the traditional methods that are currently in place. Particularly the gas that's being actively used for heating purposes, both water and space heating, can be significantly shaved off, or the dependency can be reduced if we opt for such energy efficient appliances. This can be followed by electric vehicles uptake, but it requires some charging infrastructure, of course, and integration with the grid, which is sort of that future step once the EV sort of market develops, and once the uptake is more nominal in the context of a normal consumer, for example, then methods like integration with the grid, which we call V2G, vehicle to grid, can drastically not only reduce transportation demand, but again it can be cost effective in the long run and also reduce the carbon emissions. Smart urban energy nexus in the form of VPP, virtual power plants, can significantly reduce not only the load, but also warrant its cost effective utilization while reducing the carbon emissions. Now, some of the next steps that I've included, and by far this is my thinking only, so there can be many more to this, are some of the, government should implement building codes and promote energy efficiency, efficient technologies. I shared a case study for Victoria in which, there was a process, or there was a program that basically implemented, these standards first, and then followed by the uptake of solar PV battery systems and more energy efficient appliances in order to tackle these urbanization problems. Regional cooperation in urban energy management, for example, what's going along in different SAARC-based countries or other developed countries, taking the learnings from those case studies, examples, projects would really help out. And we can always sort of taper or shape up those strategies in terms of the problem on hand for any particular country or any particular city, and act upon accordingly. Some of the technology recommendations to start with are scale up rooftop solar and battery storage in urban areas, and then encourage adoption of smart grid technologies for real-time energy management, which includes upgrade of the infrastructure and better shaping of the interface between both the consumer side and the generator side or the distributor side in order to tackle this problem in a more smart and energy efficient way. Uh, I think that's all from my side. I'm happy to answer any questions and really looking forward to the rest of the webinar.
Thank you very much, Dr. Abbas Ehsan, for your detailed and very nice presentation highlighting almost all the key areas along with recommendations. So I'm really thankful to you. And well, yes, of course, there are a few questions because your presentation was, I mean, people are so much interested. So I got few questions, but considering the time situation, I will deal them accordingly. The first question we received is regarding the same case study you mentioned in the end of your presentation, that you mentioned a case study of Australia on uptake of solar PV and energy efficient appliances. So can you provide more context on this and what learnings can be applicable in SAARC nations?
Yeah, that's a very good question. And I think to start with implementation of energy efficient appliances, it's sort of a twofold problem in which you look into what is my current problem space. We all know solar PV can help and contributes toward significant energy savings in the first place along with battery storage, but increasing my energy efficient appliances or adoption of energy efficient appliances would help cater this problem even further. So for this, the Victorian government here in Melbourne looked into the same problem like five years ago, starting from rooftop solar PV, and the learnings. Like I can share the learnings as part of my answer as well in parallel, that they started with the uptake of solar PV and battery initially like 5-6 years ago, and now in the recent years, like a year and a half ago, now they've slowly switched towards uptake of energy efficient appliances like adoption of particularly reverse cycle heating and cooling. So like now, whenever a new house is built or a new entity is built, they are required to be more efficient because there are better building codes in place, better efficiency standards in place in order to and they also cut off gas actually as a primary energy consumption. But it's a cost on the consumer, as we all appreciate that. That's why they introduce some subsidized programs in order to help the consumer in order to adopt to these more energy efficient technologies like reverse cycle hair cons, hot water heat pumps, and electric cooking based technologies as well. I hope this answers the questions in some context.
Yeah, it's quite clear, and I believe you have addressed in much detail. There is another question. Participants from Sri Lanka, he wanted to know that what role, though let me first elaborate that yes, you have covered in general, but maybe he wants once again to put some light on the roles that technology does play in managing urban energy demand, and how can smart city solutions help optimize energy use in growing urban environments. So that is a bit, I think, interesting part.
Yeah, exactly. The smart urban energy planning, part is I think we covered most of this context already, but to give a quick recap, is the infrastructure plays a key role here, the which can basically lift up the consumer side. If, as I said previously, if we have energy efficient appliances installed at our homes, but the infrastructure is not there to support it, it's sort of a bit of a misbalance. So technology is really crucial, but both from the supply side and the generation side. So I would like sort of emphasize towards the uptake of, or the upgrade of the existing infrastructure, and then development of better interfaces in order to use those assets more efficiently, not only by its primary consumption, but by strategies like demand response and overall participation of those consumers in the distribution network in order to help the grid actually. So for example, if I have a battery at home, I can help the grid with the fluctuations of frequency, but provided the systems are in place over there.
Well, thank you very much. I think I should stop here with you and with these questions because we are getting short of time, and I would request, and first of all, must thank you again. And I would request that please keep your camera on so that I can have a screenshot with both of presenters. While meanwhile, I may inform our participants that our next presenter is Mr. Marele Gunatelike. Mr. Marele is a chartered electrical engineer with over 33 years of distinguished services at the Ceylon Electricity Board, Ministry of Power and Energy, Government of Sri Lanka, where he retired as the Additional General Manager. Throughout his career, he played a pivotal role in modernizing national power systems, particularly in optimizing hydrothermal dispatch, load management, and overseeing technical operations for the Ministry of Power and Energy. He was instrumental in shaping the regulatory framework for Sri Lanka's electricity sector, contributing to key legislation such as the Sri Lanka Electricity Acts and the Engineering Council Act. Post-retirement, Mr. Marele has transitioned to consultancy role, contributing to power sector reform projects under ADB and World Bank funding. His wealth of experience in technical oversight, regulatory frameworks, and policy formulation makes him an invaluable expert in the field. With this brief introduction, I would like to request Mr. Marele Gunateleke to proceed with his presentation on urbanization and energy demand, the strategies for optimal response. Over to you, sir.
Thank you, Insan. Many thanks for this introductory remarks. You all can hear me? Perfect.
Yes.
Thank you. Good morning and greeting from Sri Lanka to all of you in the SAARC region, and also our friend Dr. Abbas from Australia. I also take this opportunity to convey my sincere appreciation and thanks to Director of the SAARC Energy Centre, Your Excellency Dr. Nawaz Ahmed, and the Program Coordinator and the Research Fellow, our good friend Mr. Mawal, and all other officials of the SAARC Energy Centre for giving me this wonderful opportunity to share my little knowledge and experience in this important webinar. At the outset, let me confess that my relationship with the SAARC Energy Centre goes way back to 2008. This was the time when I commenced my new posting as the Director Technical at the then Ministry of Power and Energy of the Government of Sri Lanka. I also can remember visiting your place for the first time in 2008. And since then, I was involved with many of the projects conducted by SAARC Energy Centre. and with various capacities. And I also ended up as the member of your governing board, and also just before my retirement, I became the chairman of the government. And thank you very much for your wonderful service. And I'm happy to see almost nearly 2 decades since the inception, the SAARC Energy Centre has gone from strength to strength, mainly due to the commitment and dedication given by officials like you. So we hope that this trend will continue in future also. So coming back to the today's webinar, and also the topic given to me is urbanization and energy demand strategies for optimal use, optimal response. And I must confess that thank you, Dr. Abbas, for the excellent material given to the participants, especially the technological solutions and innovative approach by you, and covering mostly the challenges and the solutions, and also smart solutions, and also the mitigatory strategies. So I will not be going into details regarding those technological solutions, but would like to stress more upon the urbanization concept per se, especially with regard to our sub-region. So with these opening remarks, there is a remarkable change, a paradigm shift on the entire power distribution system. Say, when we started our studies like about 30, 40 years ago, we never heard about a consumer producing electricity. We never cannot even comprehend that concept. But however, the entire technological scenario, this is as the technocrats, most of us, the issue is to how to address this technological transfer. Like earlier concept was supplier or distributor and the consumer. But this concept has been challenged by the present scenario. So I'm going to share my, from this time onwards, I will share my screen. So you all can see my presentation. And
Yes, very visible. Very
now
right.
you can
Smooth and dynamic.
So,
yes, please go ahead.
Thank you very much. Perfect. Now, most of us as electrical engineers or policymakers and administrators who are gathered today know few decades earlier, this scenario will be unimaginable, as I said correctly earlier, and never heard of. Therefore, the entire philosophy of electricity distribution has been changed dramatically, and I'm sure will continue to change in a very rapid way with time. So, those who are interested in this urbanization concept, I will just touch upon certain simple theories which the various scholars have touched upon. Scholars such as Tithi, Dev et al., Thompson and Lewis etc., have written many articles in this subject of urbanization. There are also many academic articles written on this subject with the emphasis or the focus on developing world, particularly in our sub-region. Why we have changed from, we are stressing upon this urbanization is agriculture and industry are two significant driving sectors or forces of the economic growth, as well as our economic development of our countries. And urbanization is a structural change due to these sectors. Now, let me now speak few words about today's main topic given to me. What are the challenges faced by the urbanization? Urbanization in its simplest form can be defined as the process of concentration of people domiciled in a particular territory or a well-defined area. Therefore, this process of becoming urban, moving to cities, shifting from agriculture to other pursuits common to cities. So we have, as a society, we have a lot of challenges. The society, the environmental, the geographical, educational, and utilities. And now those are the key variables affecting the energy consumption. And we will concentrate mostly on utilities, the stresses on utilities. So they are, because this our main key area is subtopic is actually energy. Now, having said that, I would like to focus your attention to the urbanization related to our part of the world, as I said earlier also. Up to now, we have dealt urbanization, impact of urbanization on energy demand and environmental consequences, responding to energy demand optimally, utilizing indigenous renewable resources, smart cities, and energy efficiency. Now, it is time for us to look into the mitigatory strategies and best practices to manage the increasing energy demand due to urbanization. So, what are the key variables in this subsector energy challenge? The gross domestic production of a country, industrial share in the GDP, service share in the GDP, the green technology, energy efficiency technologies in the industries, incentives for the public transport, restrictions on the domestic energy usage, awareness programs on efficient energy usage, knowledge on our own environment, and sustainable energy utilization. So one of the key challenges, if you say, is the key challenges in the massive stresses on the natural environment, resulting to move our focus on sustainable energy consumption. We need to focus our attention on how urbanization can affect energy use and identify factors that causes increase in energy consumption. Even in the, as Dr. Abbas has touched upon, even in the global context, urbanization has posed some serious challenges which are related to the environmental stresses through increased energy consumption, giving indications that our planet will face grave consequences in the near future. These challenges have drawn attention to the need to implement urbanization with sustainable energy consumption at a global level. But now, coming back to our cities again, people, as the policymakers, as the governments, it is our duty and our obligation is to give the general public necessary services and infrastructure. However, while giving these economic inputs, it is difficult for this, especially our governments of our sub-region, due to lack of capital, lack of resources, to support these economic demands from the society. So that is due to this reason only we are facing with severe issues in urbanization. This is more significant, especially in, I think, in India, Pakistan, Nepal, and Sri Lanka, out of the other SAARC countries. I will not be going into very high theoretical concepts of urbanization, where there are many articles available in the internet and other magazines. So you can, the participants can refer all these things if they are really interested. And however, we'll be focusing mainly on the strategies and remedies as a third world country, and of electricity planners and policymakers, how we should be looking into, and more importantly, focus our attention on strategic approaches. Furthermore, we also should focus our attention to the sub-regional aspects, which may be more specific to our region. Lessons learned in other regions, mostly from the developed world, can also be applied with appropriately to suit our own requirements. And as I said earlier, we are a region challenged by rapid urbanization, predominantly in India, Pakistan, Bangladesh, and Nepal and Sri Lanka. We are also developing economies. And you all know, currently in my own country, we had a lot of issues and economic issues due to severe foreign exchange issues. It is common knowledge that in the most of the developing world, cities demand more energy than the industrial sector, stressing the utilities to their limits. So, in order to give solutions to any issue, it is our duty as engineers and policy makers, as from the governments, first study this issue of energy demand and urbanization in a very analytical way. So for your review and comments, I did a sample of SWOT analysis where you can see from this presentation. Of course, there are so many things which I have put, but this is open for discussion as a point to ponder, and I will be just repeating what I have written on this presentation. And for the strengths, because this is a different perspective that I am trying to put you. What are the strengths? And some people will say a concentrated demand is an issue. But for me, as an electrical engineer, a concentrated demand is a strength, where big cities like you will have a demand concentrated on a certain geographical location. And number two is less transmission cost, as the demand is at centrally oriented. So for the transmission of the power necessary for us to transmit will be, in my opinion, will be less. And also the distribution cost, it will be a centrally distributed system. So these are the strengths, and also easy access to consumers as well as the service providers. If you go to a village or a rural area, it will be very difficult and costly for us to give electricity to each and every household. There again, the number, if you can see number 5 of the strengths, the huge marketplace. We have a huge marketplace at a centrally located. If you think that you consider this is a marketing opportunity for the distribution company. However, if you think about the weaknesses and the high financing cost due to most probably we have to go for underground solutions. And XLP, we all know XLP, cross-linked polyethylene, the overhead insulated power cables will also be expensive. And also most of these consumers are very, very poor. And the number 4, if you can see the weakness, we have less advanced technological know-how. And number 5, our consumers, mostly our population, low level of education, and we don't have any innovative approaches. Number 6, cultural habits of our population, mostly Southeast Asia. And it's very difficult for us to convince people on good habits, like less energy consumption and unnecessary lighting, etc., etc. So what are the opportunities available for our countries? I would say the green technologies, because most of our countries are blessed with sunlight, mostly throughout the year. And energy efficiency technologies are also not very high technology. We also can apply and we can do our own research and development within our region. Number 3, the public transportation. And Dr. Abbas has touched upon the transportation. Actually, one weakness of our societies in this part of the world is we all wanted to have our own private transportation. So somebody has to think and give a solution how we have to improve our public transportation. And number 4, though I put this in the slide, but personally I'm not really in agreement with this restriction on household level use, because as a power engineer, my view is we have to give the electricity and energy, and it is up to the people to use energy whenever they want. And number 5 is the education and awareness about energy use and its consequences on the environment. And as I correctly said earlier, also abundance of sustainable energy. This is an opportunity for all of us. And coming back to threats, we have severe environmental consequences and personal transport, land urbanization issues, and there are social issues due to urbanization, and difficult to transfer advanced technologies and low level of education. And having analyzed this, As per the many experts in the energy economics field, urbanization has led to increase in energy consumption in 3 different scenarios. You can see geographically the land expansion. That is number 1, spatial expansion, and the transport expansion, and the lifestyle expansion. So these are the 3 major issues to be addressed by the respective governments' policy issues. So, and also this is a dynamic process. We need to find dynamic solutions to these dynamic changes in the society. And one of the key weakness of this dynamic behavior is that most of our utilities are state-owned. And the state-owned utilities are very difficult for us to change, and change with the time, change with the environment, change with the cultural aspect, change with the technology. It is very difficult. So this is also an issue to be addressed by respective policymakers. Having said that, this theoretical concept, so I would like to summarize in 3 terms the major policies to be implemented by the governments. And there is no other option. Our governments should initiate to invest in renewable energy in a more stressful manner. Number 2 is implementing green energy efficient technologies in the industrial sector for our industries to be cost effective and energy efficient and competitive in the international market. We have to implement these energy efficient technologies. Number 3 is also very important, the raising public awareness of the negative effects of energy use on the environment through education. So what are the other pertinent points to ponder? I mean, as students or young engineers, I have put a slide number of issues that you can study. One thing is the GDP positively correlates with energy consumption. And developing economies in general has increasing growth rates and increase in energy consumption. So this is a daily increase in our part of the world. So this is very difficult for us to meet the demand. And also we are having major structural transformation from agriculture to industry. As I said earlier, key policy directives are here. And I'm recommending 3-pronged approach for the governments and the policymakers to consider. Standardization and knowledge sharing at our regional level. That's a regional approach. And amending building codes, regulations, and standards at national levels. And awareness of programs, training, and implementation support, making site-specific regulation and bylaws at the local level. So I would suggest the SAARC Energy Centre can play a major role in number 1, where at the regional level to harmonize. I know that we are doing this continuously, harmonization of standards and regulations. And
thank you very much, sir. Thank you.
Yeah, and I make it very short because of the time restrictions. But now this is I only touched upon the theoretical concepts only. But I'm available for any questions regarding even technological, no issue. Thank you, sir.
Yes, sir. Thank you very much. And yes, you rightly mentioned that regarding the standardization, labeling, and the behavioral change in the consumer. So yes, you are right. We are already working on it, and we are also planning at least two of our program activities that we would be proposing to our governing board on the same topic. So I totally agree with your point. So with this, I thank you once again, your patience, your time, and your, very comprehensive presentation. And yes, we have certain questions for you. There is a question that how does rapid urbanization in South Asia impact energy demand, and what specific challenges do cities face in meeting this demand? Though again, I'll say that we have generally covered, but maybe a participant want to quick recap on that. So if you can give us quick recap on it.
Yes, sir. Would you like to repeat it, please?
The question is that, it's covering almost our whole webinar. The question is that, how does rapid urbanization in South Asia impact energy demand? And what specific challenges do cities face in meeting this demand?
Of course, I have covered most of these challenges, but to answer that question, I would like to elaborate on his question. Like most of our challenge would be the financing. Number two, technological know-how. Those are the severe challenges. Number three is education level of our urban population, or else the cultural behavior. So these are the very difficult questions for third world countries like us and developing economies. As a former policymaker, I can very well remember how to allocate the limited funds available for health, even for education, and also for energy supply. So this is mostly everything emanates from the economics in our real life. So that is why we have to use
Well, thank you, Merele sir. I think Merele has some internet issue. So let's wait for him. Otherwise, I may divert the question to Dr. Abbas meanwhile. It is again a generic question, and again it is regarding that given the increasing energy demand from urban areas, what steps can be taken to promote energy conservation and behavioral change among urban populations? So, Abbas, would you be able to put some light on it?
Yeah, absolutely. So it's basically, I would pose this as a recap of this webinar as well. In general, that the honorable speaker already highlighted, the economics around these challenges are pretty crucial in the first place. To make an end-to-end solution, as from my presentation I mentioned, the uptake of renewable energy resources like solar PV coupled with a battery system, followed by energy efficient appliances, and then that tackled with smart grids and smart solutions that includes smart interfaces between both the generation side and the consumption side. They are pretty crucial, but when we go more smart and when we go more sort of fancy, it comes at a cost. So we should highly appreciate this, and but again, given the developments in solar PV only, for example, with mass scale production of solar PV, the costs have significantly gone down. Plus, demand response strategies and communication interfaces through distribution networks. It's not something that it's not it's not like inventing the wheel from the basics. So it's already the systems are placed in there, and it's just that we need to tackle the problem more locally as well. For example, I can speak about lots of strategies, lots of solutions, but at the end, I think the most crucial part is that what are our really local challenges. And on that, I think Mr. Merrill very rightly identified the education part is really crucial. So the more people are, or the communities are, or even the governments are, the public are more sort of aware of these new technologies and new strategies on how they can conserve energy, how they can save energy, how they can basically participate better as a consumer in the overall energy nexus in a smart urban settings. I think all this combined as an education piece, if we can develop education programs for this and convey it to the local government levels, local community levels, or starting from the starting targeting from doing some pilot projects, even targeting cities that are most getting this urban sort of hit quite a lot. We do campaigns over there, we do knowledge sharing programs over there on how what are really the challenges the current infrastructure and the current sort of system is facing, and then how what are the proposed activities that we can tackle them with. So the education piece is really important, the economics are really important, and then we sort of suggest how can we become more energy efficient by uptake of these new technologies. There are so many Chinese companies out there, there are so many and well established companies. They would happily give a very cost effective programs throughout, for example, a city level setting or maybe a local council level setting, in order to help the community and spread out for example hot water heat pumps, for example, or reverse cycle air cons, for example, in a cost effective way. And these coupled with if we can propose some developments on the distribution networks in order to minimize our significant losses that most of the South Asian countries are significantly facing at the moment, that would drastically solve or help the problem quite a lot as well. And painting the picture in complete, it's ultimately the balance of both the distribution network or the generation entities that we normally speak about, plus the consumer side of appliances level thing or the demand response level sort of strategies. Once that is balanced out, I think in a even with in sort of South Asian countries with sort of lower economies, this is not something undoable. If we can start with the education piece, start with generating our economic scenarios for what can be done efficiently, I think people would likely be happy to participate and sort of address this overall this urbanization nexus challenges, and to sort of broaden this in a long term. It would really help, as I keep saying, it's not only solving the energy problem, it's solving the huge economic problems that the energy systems in general and all in global are facing. And then we are contributing towards green and lower carbon emission based technologies and generation as well.
Thank you very much, Abbas. You make my life easy. You did what I was supposed to conclude, and I really appreciate and I really, agree with all the points. Rather, it's economic, it's a social, it's behavioral, it's technology. So everything has to come across together, and we can achieve our ultimate goal. Frankly, on one side, we are lucky, rather, we are unfortunate with a new type of challenges, but we are lucky enough that we have sort of a variety of solution to address all these challenges. and the challenges are more or less similar, but we at national level, at regional level, but we have to look across for the communities, for the cities, at local level, and every individual has to take part in it, whether it's rooftop solar, whether it's a smart grid system, or it's a localized utility scale power generation through renewables, or its energy efficiency, and then it's ultimately the behavior, and everything collectively is linked under the umbrella of this economic situation that we have this major challenge in South Asia. And again, welcome, Mr. Mirele. We have a good session with you, and I would like to say that with this, it's a collective effort to achieve our targets, and maybe this is one of the urbanization challenge, whether it was electricity or energy breakdown, you were disconnected, or it was internet challenge. So the both are ultimately challenge for urbanization. I mean, there are some. I mean, we should look upon it. So once again, I thank you, Mr. Murali Gunateleke and Dr. Abbas Ehsan, for sharing your knowledge and taking us through the details. And once again, I should thank you for your excellent response to the queries raised by the participants. So, ladies and gentlemen, we came across many interesting and useful information through the presentations and discussions. Today, good experiences are shared by the participants and presenters. I would like to pay my deep respect to all the participants for enthusiasm and active participation in this meeting. Finally, I would like to thank my colleagues for organizing this event and ensuring it ran smoothly. I would like to officially announce the closing of this workshop. I wish prosperity of South Asian nations. Thank you for your attention. May God bless you all. Thank you very much. Bye-bye.
Thank you.
Thank you, sir.